Here's a video that shows an approach for the respiration data, and it's basically doing power spectral analysis in EMSE. So let's see how that works. Oh, by the way, what I'm looking at is some data you provided. I turned off all the channels except for some of these that you've been interested in lately. And I also have this here, this derived ECG channel, which I think I showed you before, but just to show you that again, this is a derived channel, which is EXG3 minus EXG2. Okay. We'll ignore those, but when I do the power spectral analysis for the respiration channel down here, who knows, it might be interesting to see what the same results are on these other channels. So okay, let's see what we want. So we've got three conditions. Baseline, which in this case you said was between 100 and 357 seconds due to a glitch there. Then we've got 6 cycles per minute paced breathing between 170 and 171, and 12 cycles per minute 110 and 111. Okay, so I already entered these. I'll just show you what I did. So I'm going into Edit, Events, and I'm going to add some intervals. So for example, here, this baseline, I clicked on Add, and here I went, I'll just call this a test. Give it a color of some sort, any one you like, and you don't need to make it visible. If you make these long events visible, it'll cover up a lot of data. So you don't need them to be visible in order to use them. But the main thing is we want to add an interval here, start and stop. So let me cancel this and show you what I did for baseline. Now I'm just editing the one I already put in there. Notice we have, for all these other events, the start and the stop are equal, but for this one, baseline, it has a start of 47.702, which happens to be the same start of event 100, so it starts at 100. That's where I got the 47.02. And the 357 is what you told me in this case. So if I go into baseline, edit, I put in those two numbers. I gave the event, in this case it's an interval, gave it the name baseline, gave it a color of choice, turned off the visible property. And now we've got this one ready for analysis. But while I'm here, let's look at we'll do the same thing for the other two. So let's see what we've got here. Okay, here's the 12 CPM. Okay, so you'll see in here I put 12 CPM, if I edit that, between 586 point something and 1999 point something. You told me that the 12 CPM was between events 110 and 111. So that's where I got those numbers from. Let's see here. The 110 is right there, so that's where I got that number. And the 111 evidently is down here a ways. There's the 111. That's where I got the 1999 number from. Okay, now we have the same thing for 6 CPM. I'm showing it here between 2239 and 3672 seconds. You told me that 6 CPM was between events 170 and 171. So let's see here. Here's 170. That's where the first number came from. And 171. Let me scroll down here a ways. There it is, 3672. That's where the second number came from. Okay, so now that we have these events added to the event file, and these are intervals, that's the key thing, is that they define intervals. By the way, if you had multiple periods of the same condition, you could add them here. Just give them the same name, but with a different start and stop time. So let's say they have paced breathing, interleaved with something else, and you want to group it all together. The analysis I'm about to show you can combine all that together as long as you give them the same name. Okay, so that's what I'm going to show you now. Okay, so we'll go to Analysis and PowerSpectrum. And now we've got these different choices. Now here's the key thing here. The first thing to select for the data window is consecutive within segments. So those are the segments we just defined. We're going to pick one at a time. So we're going to do a consecutive window within segments. Here's another thing that would be ordinarily quite unusual for EEG, but I'm going to make the window duration 100 seconds. Why? Because the power spectral resolution is the reciprocal of this number. So, and you've got lots of data. Each one of these segments is more than 100 seconds long. So by picking this number, we're going to get 1/100th of a hertz resolution. 1 over 100 is 100th of a hertz. Right. So let's see if that works for us. And then let's do overlapping 75% windows. So what's that mean? So you take one of your intervals. We're going to take a 100-second interval, and then we're going to shift it over by 25%. So it's over. So the next window will be overlapping 75% with the first window, and we'll shift them over 25% like that until we get to the end of the interval. If we happen to have multiple intervals with the same name, then it will jump to the next interval and do the same thing and accumulate the information that way. Okay, always use cubic spline interpolation. You can leave these alone. Now I'm going to go to next, and now the key thing is to select one of our choices. Let's do the 6 CPM first. Okay, we can see we just selected one of them, and we have not put we've not put a filter in the pipeline, so it's not necessarily to do this filtering interval option. We can just say interval of interest. We don't need to cut off the high frequency, and we don't need to estimate covariance. So I'll say next. And here's where if there was some bad data in there, one way you could deal with it is just to make an interval that make multiple intervals that have just the good data that you selected by eye. Otherwise, I'm not sure what the right units would be for rejecting respiration. So I'm going to skip this one. But if you know that there's some magnitude limits, you could select the respiration channel and set a max. I'm going to skip that. Next. And I'm not going to do any detrending or polynomial fitting. I'll just say finish. Okay. Let's see how long this takes. These are long windows, so we'll take a little bit of crunching to do them. But it found 54. And by the way, I am using EMSE 6.4, which is 64-bit. So if ever you run out of memory because of the large intervals you're using, I recommend using the 64-bit EMSE. That's 6.4. Okay, so that's done. And now I already created one once, but I'm going to overwrite it. So this one here, PSD 6, 100 seconds. You can see I tried it with a 60-second window. You might think 60 seconds is reasonable because that's 1 minute. But when it comes to getting the final hertz, you might want to see it in hundredths instead of whatever a fraction of 60 would be. So, okay, I'm going to overwrite that one. Yes, I'll replace it. And here we have it. Let's just focus on the response channel. This coloring, it's just kind of another indicator. You can change the color however you like. For example, I could turn this red if I wanted. The goldish color there is really the default color for any channel that's a pass-through channel. And you can auto-range them here if that turns out to be convenient so that you can see the whole thing. But let's see. So here we have a PowerSpectrum, and we've got a long range. So let's we really want to zoom in. I see this right-click arrow. I just really want to zoom in to the very, very low end of the spectrum here. Now notice we're in. If I go zoom in on that, notice we're in millihertz already. These are slow frequencies, and which are perfectly appropriate for, say, fMRI and slow-paced breathing. Okay, so so now here we are. This is the nicest and clearest cut case, the 6 hertz. We've got this really nice peak, which happens to fall exactly at 100 millihertz. So there's our resolution now is now this is at 110 millihertz and so forth, because we selected a resolution of 1/100 hertz. So our resolution is going to be in units of 10 millihertz. That's the resolution of our spectrum here. Okay, so we definitely have a peak that dominates at 100 millihertz, which we don't need a calculator for this, but we know that just so you know, point 1 hertz times 60 seconds is 6 cycles per minute. Okay, so that's right on there. Of possible interest, when you do this power spectrum analysis, you also may see other peaks. So there is this other one. You might end up taking an interest in this one, which is a little slower. Has something to do with their breathing patterns. A couple other smaller peaks at some others, but this one clearly dominates. Okay, so now the thing is, we want to do these other two conditions. So I'll go back to the PDF file, analysis, power spectrum. All this I'll keep the same, except on this page, what we're doing next, 12 CPM. Let's do the 12 CPM. This one, I'll select that one. Interval of interest, I don't need covariance. Next, next, finish. Just to see if how much memory I'm using. Oh, we're fine with memory. That's pushing half of a gigabyte, and that's plenty even for 32 bits. Okay, we found 53 windows. That means these are the overlapping windows. So 100 seconds, the first 100 seconds is one shifting over by 25% or shifting over to 25 seconds, and overlapping, shift over by 20 seconds, overlap. There are 53 of those total that are included in this power spectrum. And I'm going to overwrite the one I made before. Say yes there. And now we've got the other one. And once again, let's turn up everybody here. I won't change the color this time. Main thing is when we compare it, we'll want it to have different colors. So but there again, we'll want to zoom in by pressing this right arrow. That's shifting the whole spectrum over here. Okay, and now we see, maybe I will change the color if that's not totally clear. Let's make it blue. Okay, it's a little more clear. So now we have a peak, but we'll see when we compare it with the other one that the peak, the amplitude is much smaller. Once again, I don't know what the units are of the respiration, but relatively speaking, it's on the same scale, so it's smaller. We also have a couple other peaks. So this peak here is at 0.14 hertz, which let's see where the calculator is. So 0.14 times 60. So that's 8.4 CPM, which isn't the target of 12 for some reason. Oops, I was shifting around there. Should have done that. Let's see here. What happened to my calculator? Shouldn't have been waving around the cursor there. Okay, let's see. So let's come back here. Well, we saw that was 8.4. But let's look and see what this other one is. There is another rival peak that is higher, and that's at 0.19. So 0.19 times 60. That's 11.4. So that's pushing the target. That's getting pretty close to 12. Okay. And also there's another peak here. That's at 0.7. 0.7 times 60. Oops. Zero 0.07 times 60. Sorry, it's the end of the week and my fingers up. So that's 4.2 hertz. So you might think that these peaks are, you know, there's some the rhythm of the breathing is not perfectly sinusoidal. It's not. It's got some other components to it. So that might be of interest to you. Okay, we'll finally do the other one. Let's see. Let's just say okay there, and let's do the last one. PowerSpectrum. Keep all that the same. This time I want to select baseline and interval of interest. Let's go ahead and finish. It didn't take as long because the baseline interval was not as long. So we had 9 overlapping windows there. And I'll overwrite this one. And another thing I can do, I could just zoom into this one directly. I'll double click there. And we can zoom out. Okay, so here we have a dominant peak right there, although that's kind of, there are 2 of them there, but there's one. The peak is there, which is at 0.13 hertz. Times 60. 7.8. Okay, so that's means that the baseline respiration rate is about 7.8. But you can see there's also a little bit of variability in there. Okay, now let's overlay these. So now what I need to do is let's pick one as our, let me pick the one that's the largest first, because that'll sort of set the scale. By the way, I don't know what these units are. Ignore the microvolts squared. If we do find out what the units are, we can relabel the units. Okay, so now let's see, let's unload these so I can overlay them. So I'm going to now make sure this one is last selected. Right click on this one. Right click overlay. Oh yeah, there it was. Sorry. I did it twice. I didn't wait long enough. And then we'll do the baseline as well. Okay, so now we have the overlay on these, which is basically just showing what we saw when it zoomed in. But now, relatively speaking, we can see that the amplitudes are quite different for these. And then I think I also showed you something about, because when we did this one, we also had the other channels available. So if let's just say we want to look at the GSR channel. Let's go back and that's right. Yeah, we're in chart recorder mode. So if I just want to look at the GSR channel, let's turn everybody up. Let's see the GSR. Okay, so there we are in these three conditions for the GSR. Now this isn't the kind of analysis that most people do with skin conductance, I believe. But nevertheless, I don't see a reason why you couldn't do this. This is auto-ranging all the pass-through channels, so if I want to rescale it, I need to uncheck this one. Okay, but just of potential interest, this one, this little peak here for the, which condition are we? We're in the 12 CPM case, has a peak there on the GSR channel. And you might find some interesting correlations, I don't know, between the GSR peaks, skin conductance, and respiration. Anyhow, now it's yours to play with, so I'll leave it at that.